should be live. There's only me, though. There we go. Let me see your mug.
I think
Your tea mug.
it's really pretty.
That's cool. Carla would like that.
I think I got the forums back online by kicking them.
Oh, that's all it took. Turned it off, turned it
Yeah.
back on again.
Yep. Okay. I'm not going to question that one, but the forums are back. I'm going to respond to the sad people of Twitter. I love you all. I hate servers sometimes.
Sometimes?
Sometimes I love them. It's one of those things. I have a love-hate relationship with technology.
I just hate it. All of it. All the time. You just clearly, I
Yeah.
don't know, you clearly just haven't spent enough time with it breaking your heart.
I'm not sure, but it's also saved me so many times.
Right, but isn't it just it saved you from a situation that it created? I don't know.
Um,
I think you have some kind of Stockholm syndrome with your
no.
technology.
I mean, you're just not going far enough backwards. As someone with dyslexia,
Hmm.
I was relegated to like the most remedial of everything until I got my hands on a computer. And then all of a sudden, they were like, "Oh, she's gifted and talented. We'll actually teach her now." And so that one thing
Right.
got technology a huge buy on everything that came
But you
after.
see, so I think that's technology's way of sucking you into its
It's
vortex of
true.
sadness. No, no. As I say, I am turning into a Luddite. Turning into a Luddite. Let's smash them all. I like computers. All right. Hey, good news. The shutdown is over.
Well, they still have to finish the voting and checks won't get out today. So, yeah,
Still,
it's
like,
I will feel better when people receive checks.
right. But let's hope that people receive checks. But still, good news. I mean, just when you think of see how many people who were um, without any money for a long time, it's been pretty rough. So I'm really glad, and I want to hear all the news. Like the spacecraft were still exploring various places. What did they find? So I suspect we're gonna just get this just enormous data dump from everybody at NASA going, we found this, we found this, we found this. Let us know if you need any more information. All right. I'm going to say hi to a bunch of people. Hello to Andy Cowley on a post, Astro B, Balt VDB, Bill K, Bruce Bushy, Capital H, Colin Jones, Daniel McCool, Doug Ellis, Enoch, Esther Gagne, Giselle Sabarin, Gordon Dewis, Graham W., Guido Bibra, Jason Elric, Jim Becker, John Drake, John Seffield, Kevin Ayers, Quad Libet, Larry Beckham, Linda Sedik, Nancy Graziano, Paul Gracie, Rick Schwartz, Salad Snake, Sergio Botero, Steve Heistand, Tom Van Scotter, Umu, Will Peppers, and Zapfan Zapfan. Hey, everybody. All right. So if you're wondering what it is that you've stumbled into, this is going to be an episode of Astronomy Cast. We're going to record the episode, and then we're going to stick around for a few minutes, answer your questions. I might have to book out a little bit early because
Okay.
we have a drive that we have to do to about an hour and a half away. So, but we'll see how that's
And
going.
I am just trying to keep up with all the things going on. And in this world of so much insanity, I could use any extra 5 minutes.
Shut down all of those things. Be present here in this moment.
I am now present. I have now let everyone who was sad facing me on all the different things
Yep.
know that the CosmoQuest bout forums are functional again
Yes.
for now.
Okay. Are you ready?
I believe so. It
Okay.
claims that it's using all of the correct inputs and outputs and puts.
I'm gonna let this dog finish drinking.
We haven't seen your new
You
dog
haven't?
yet.
Okay. Well, let's summon the new dog.
Okay.
They haven't seen the dog. This show hasn't seen the dog.
Nope. We need to.
All right. Come here.
I love it. Looks like a cartoon dog.
Yeah. This is Ona, and she is deaf. So she can't hear that she's a good dog. But yeah, she is another bull terrier, and she has this black eye, which is so cute. And she is such a sweet dog, like just a total cuddler. Doesn't like
Except for right now.
right
She's
now.
like,
She's not,
I
yeah, she is not pleased. Not pleased about this. Yeah. So, all right, I'm gonna put her down. That's it. It's over. That was funny.
You training her with big hand gestures?
Yep, yep. So we've learned how to say sit and good dog and go for a drive and go for a walk and all this kind of stuff. So
That's awesome.
um,
Yeah. I had a nearsighted deaf dog, and so there were big arm gestures that
yeah,
were required.
yeah. No, but the problem is she just like also has this bull terrier. Uh, like she's just like impossible to get her to do anything. She's so stubborn. So it's a hilarious thing when you try and you know they aren't easily trainable dogs. So and it's
Are
tougher.
they where the phrase bullheaded comes from?
Maybe I don't know. Um, they're in the terrier group, so they're pretty funny. But they're just total clowns and very cuddly. So she's a good dog. She's a good dog, but she can't hear that. So she has no idea that she's a good dog. We just go, good dog, you're a good dog. All right. Let me know when you're ready.
I am ready.
Okay.
Shall I press record?
Hold on. Let me press record. I press record. Okay.
I am recording.
Okay. Here we go. Astronomy Cast, episode 515, Space Radiation. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. We just got the news. The shutdown is over. Hopefully people are going to be getting their paychecks. The science is going to be rolling out. The rovers, the telescopes are still gathering data. We just didn't know what happened. And so now we're going to find out. So I think everyone should just like buckle up for a news storm of space news.
I hope you're right. I suspect that it's going to be more of a slow roll as everyone panics for 3 weeks to find out if the
it's coming
shutdown.
back. Right.
Yeah.
But I mean, as a person who has to troll. Anyway, as I have to look through all the news every day, I would say a third of the news that we get comes from NASA directly. Pictures from the space station, pictures, information from the missions, press releases from the projects that they're working on. And it's been rough to not have access to these sources of news. So I'm so glad everyone at NASA is going to be back, and I can't wait to get all the signs.
Well, don't count your votes until they're cast. There's agreement that there will be an agreement, but they haven't voted yet. I'm going to hold my breath.
Sure.
Not literally.
Yeah, I may have to take this all back next week when the vote didn't go through and the shutdown continues. But I hope not. I hope we will get to see tons, because I miss all these missions.
Yeah.
What happened with OSIRIS-REx? It's at an asteroid right now. What's happening with Parker Solar Probe? Anyway, here we go.
That was a long sidetrack at the beginning of this episode.
Yeah, anyway.
Hello, we love you all. We're actually here to discuss space radiation.
All right, let's do it. Space is a hostile environment in so many ways, but one of its worst features is the various kinds of radiation that you can find. When astronauts go back beyond the protective environment of the Earth's magnetosphere, What are the various kinds of radiation they'll encounter, and is there anything we can do about it? Space sucks. We've mentioned this before, mentioned this again. It's the worst. The entire universe is trying to kill you, and the radiation
Every day.
every day, and the radiation is just one example of the ways that the universe has it in for you. What kind of radiation is out there?
Well, in general, we're looking at three different kinds of radiation. And we're going to go through them in Greek alphabet order because one of the things that happened in science is they discovered the radiation forms before they figured out what they were. And so they gave them these awesome names: alpha particles, beta particles, gamma particles. Uh, and then we figured out what they are, and they're far less interesting, it turns out. So alpha radiation uh, is the lamest of all forms of radiation. It can't even penetrate your skin. So as long as you don't eat it or inhale it, you're okay.
Right.
The problem is you can eat it and inhale it. So this is the kind of radiation that you get from like radium, radon, uranium, thorium, just regular everyday nuclear breakdowns. And yeah, it's lame, but it will still harm you, cause death, destruction if you're exposed for too long. Now, going back to we named it before we knew what it was, and when we figured out what it was lame. It turns out alpha particles are just ionized helium atoms. And so, since helium doesn't generally pass through your skin, you're good until you inhale it. Now, not all helium is alpha radiation. Otherwise, inhaling balloons would be a deadly thing to do.
Right.
Um, so here we're looking at specific forms of high energy helium that is ejected, bereft of electrons when nuclear breakdowns occur.
Okay. Those are alpha particles.
Those are alpha
But
particles.
I mean, we don't just find those in space. I mean, you're laying the groundwork here for the different kinds of radiation that you can experience,
Yeah,
and then we'll talk about where we find it in space.
exactly.
Okay.
And you do find these in space. Uh,
Yeah, we'll get to that in a
they
second.
Yeah. So then we have beta radiation. So alpha, beta, we're lame. These are, again, particles. Here we're starting to look uh, more at like electrons. So here you have a high energy electron sent your way. And here they can penetrate your skin, but they don't get too far in. If you're exposed to beta radiation for too long, it will harm your skin. It it's not going to kill you quickly. And for this, we are glad because beta particles come from things like carbon 14, which is everywhere. We use it for carbon dating. So, beta particles, kind of lame. High energy electrons, they happen, they're everywhere. We also get them from things like tritium, sulfur 35, all these regular everyday radioactive particles break down, throw off beta radiation. So, alpha beta.
Okay. I think you're saving the worst for last, aren't you?
Yeah, I am. So far we've gone particle, particle, and now we're kind of looking at gamma radiation and also X-rays. They forgot about X-rays when they first named things, so they kind of get lumped together. This is photons, which are both a wave and a particle, and well, so is everything else, but have no mass, so they fall into their own thing. We call them light. Uh, Gamma rays and X rays, these start to pack the kinds of energies that will blast apart your molecules. This is bad. This is
Unless
very
you're the
bad.
Hulk.
Or Spider Man, I guess.
Yeah.
Spider Man did
Well, wait
pretty
a minute. He
good.
was bit by a radioactive spider, and so I'll
And
bet
he
you it
got
was right, but I'm
superpowers.
guessing it was more of an alpha or a beta particle when you think about it, right? While the
That
Hulk
would make
got hit by
sense.
gamma radiation and who knows what the Fantastic Four got hit by. The point is, don't count on any of these kinds of radiation to give you valuable superpowers.
No, they might give you unvaluable, deadly mutations.
Right.
So avoid,
Yeah.
avoid.
Right. Um, but so the gamma radiation, this is the electromagnetic radiation that's caused by stars, by supernovae, by nuclear reactors, and they're just like light, but just way at the one end of the electromagnetic
Yeah.
spectrum and bust up your
And
DNA.
And there's all sorts of different ways to produce both gamma rays and X rays. If we required radioactive substances to produce X rays, it would be a whole lot more dangerous to go to the dentist. So it's just light. They just have to produce high energy light instead of like Hugh Phillips bulb light. Um, but those are the primary kinds of light that were easy to detect in the 1800s, which is when most of these things were first identified. Nowadays, we know that it's not just the alpha particles, which is helium, it's not just the beta particles, which are generally electrons. It's not just the gamma rays and X rays, which are light. There's also these nasty critters called cosmic rays. And cosmic rays are where you start to impact energy on mass. So here we're starting to look at bigger nuclei. We are starting to look at things that can be 100,000 times more powerful than gamma rays.
All right.
And gamma rays will kill you.
Right. All right. So let's go back around to the beginning now. We've sort of classified. Essentially, you can have protons, you can have electrons, you can have particle photons, and you can have like blobs of various particles
Nuclei.
mashed together. Um, those are the flavors that you encounter. So when you go to space, when do you encounter these different kinds of radiation? So
The
what's
most
the
common things you're going to encounter in space are those nasty cosmic rays. They are coming at you from a combination of the sun, from distant supernova, from the accelerators that we call accretion disks in the center of distant galaxies. All of these different high power magnetic field systems are accelerating atomic nuclei just like CERN and Fermi, except towards us. And if you're not careful, you're going to catch the wrong kind of cosmic ray.
and these cosmic rays are relentless. It is like a fog. When you get outside of the Earth's protective magnetosphere, it is like this fog that is constantly going on, that you are just receiving, you are bathing in these high energy cosmic rays, and there's no place to run and there's no place to hide unless you hide. But unless you put some
Fair,
mass, unless you
fair.
put some protons in between you and the cosmic radiation. But the point is that while you're out in space, it's walking around on the surface of the moon, you're going to be getting a constant, relentless dose of this radiation. What are the effects to astronauts?
Well, so far, we haven't generally sent astronauts, except for Apollo astronauts, beyond the Earth's magnetic sphere. And this is where we are actually kind of lucky to live on a planet with active volcanism and tons of earthquakes because that internal dynamo that is driving plate tectonics is also driving a magnetic field that admittedly is on the run and currently escaping across Siberia,
Yeah.
but is still generating a powerful enough magnetic field that particles that are coming at the Earth are in general either caught up in the magnetic field, creating our Van Allen radiation belts, or they hit our upper atmosphere, which also serves to protect us because collisions between these cosmic rays and particles in the atmosphere end up breaking the cosmic rays and generating a cascade of lower energy particles. This is Shrinkov radiation that we can detect here at the surface of the planet. So, between this combination of a planetary magnetic field and an atmosphere, a lot, not all, but a lot of the cosmic rays get broken down into harmless bits and pieces.
So it's interesting. NASA's Curiosity rover, when it flew to Mars, it did the long multi-month journey, and it carried an instrument on board called the Radiation Assessment Detector, or
Yeah.
RAD, and it was essentially trying to figure out what kind of exposure astronauts would get over a mission like that, so that if you know that you're going to be sending astronauts to Mars in the future, just see what happened to Curiosity and then do the math. And so the problem is they got a lot. The Curiosity rover got a lot of radiation, and it's almost entirely from this galactic cosmic radiation that you were mentioning, this nonstop fog that's just out there all the time doing damage. I'm trying to find the exact number, but it was something like a essentially it's just an enormous increased risk of developing cancer over the lifetime of an astronaut. You do a mission to Mars, spend some time, jumping around the surface of Mars, looking for Mars bugs, and then you come home. You will experience a dramatically increased exposure of radiation over that time, and there's really no way that we know to avoid that. So that is and I'm surprised you went in this order, because that's like the worst one. And you also mentioned the other forms, which is the trapped radiation that we see around planets, and then there's one other I want to get into. So let's talk about the trapped radiation, the Van Allen belts, etc.
Right. So the Van Allen belt is essentially a um, set of, and it is actually two different belts that go around the Earth at different altitudes. There are temporary additional belts that can form and dissipate. And these are places where the Earth's magnetic field is like, and I shall keep you to high energy particles. And so high energy particles that would otherwise be happily making their way through the solar system, perhaps careening into our planet's atmosphere, careening into our planet, careening into us. Instead, they get bent by the magnetic field, just like iron filings do when you play with iron filings in a magnet. And where iron filings will lock into the shape of the magnetic field, these charged particles that already have a trajectory are simply going to get bent into following those field lines and orbiting around our world, caught up. And here, orbiting isn't quite the right word I should be using. It's orbiting in the sense of something going in a circle, caught up in this magnetic field. Now, the lower of the two Van Allen belts is actually higher than low Earth orbit. The Apollo astronauts, when they went to the moon, they actually steered around the lower Van Allen belt, going above it, and they very briefly passed through the upper belt. We do everything that we can to try and prevent people in spacecraft from going through these belts and enduring long periods of time there. And we've actually gotten into the habit, which is a good habit to have, of just kind of shutting things down when they pass through the belts in hopes that any additional charge dumped into the system through an interaction with this charge in the belts won't melt our circuitry.
And all the Apollo astronauts were wearing a dosimeter on
Yeah,
their
dosimeters.
yeah on their spacesuits while they were doing their pass through the Van Allen belts. And I think NASA had set some amount of rads or millisieverts that they were able to receive during that mission. And actually, after they did the missions, they only ended up with about 1% of the radiation load that NASA was concerned about. So, in fact, as you said, avoiding the lower Van Allen belts, moving quickly up and over the higher Van Allen belts really minimized the risk. That's for the Earth. But if you go to Jupiter, it's so much
Don't.
worse. Yeah.
Yeah, so the radiation levels that are allowed are actually set in the United States by the Occupational Safety and Health Administration, otherwise known as OSHA. They're federal guidelines, and NASA has been able to get a variety of waivers allowing astronauts to receive higher dosages than your average employee working at like the pharmacy down the street is allowed to receive. The Apollo astronauts, as you said, though, did receive far less than that OSHA limit they were worried about hitting up against the high end of. Now, this was in part due to luck. The sun behaved quite nicely while the astronauts were up on or around the moon and out away from the protection of our magnetic sphere. So, yeah, we got really, really lucky with the Apollo astronauts, and this isn't the kind of thing we want to rely on, and we don't want to only send people to Mars during like solar minima or
Right.
things like that.
But that's, I mean, that's a whole other issue. Is, we've got the trapped radiation that is around the Earth, the Van Allen belts. You have to navigate, go quickly. Don't rely on your electronics while you're doing this. You've got the galactic cosmic radiation that is this constant stream, and then the wild card, as you mentioned, is the sun, which
Yeah.
can be completely safe or deliver a lethal blow to astronauts in a matter of hours, depending on the level of activity on the sun. How bad can that get?
Um, well, it can get bad enough to destroy spacecraft. We've had coronal mass ejections that have, as the charged particles that are part of the coronal mass ejection pass through spacecraft, they will burn out sensors. They will add their charge to the internal systems, doing the moral equivalent of blowing fuses. And then they'll also shake the Earth's magnetic field. So, when you move a magnetic field, this then generates electricity in nearby objects. And when that electricity is generated in the Earth's power grid, as has happened in the past, this will also blow out the Earth's power grid. So here on Earth, we can have our spacecraft destroyed and our power grid shorted. And this has happened in the days before we had the low power, highly sensitive electronic systems we have today.
Uh oh, we lost Pamela for a second there. A tornado, a solar storm. Who knows what it was?
What was it?
I don't know.
Coronal mass ejection?
Yeah, that's what I was proposing. Yeah, it's coronal mass ejection.
Okay.
Sorry, Susie.
Yeah, okay. So to go back to what I was saying about modern electronics. Um, if any of you ever tinkered with a radio or a television set back in the 60s or 70s, you remember being able to like manhandle the wires with tweezers and pliers and check things with your sensors with your little box you picked up at Radio Shack, and you could play with the system. You had to make sure you didn't accidentally hurt yourself with a capacitor, and in general, you weren't going to destroy anything. Today, our electronics are much smaller, they're much more fragile. I certainly wouldn't be using any of my pliers that I've had since undergraduate to fix anything I like today because these are too big for any electronics I probably still own. With this reduction in size, with the reduction in required electricity, we also have circuits that are much more sensitive to that one stray cosmic ray hitting the wrong piece of silicon and breaking through the molecule thick thin film and destroying your whatever it is that you love.
So let's talk about prevention, safety. What can you do if I mean, the plan, right? The Orion capsule is under development right now. The Space Launch System is in development. They'll probably fly. Um, the, if not them, there, of course, is all of the work that SpaceX is going to be doing, sending hundreds and hundreds of people to colonize Mars. What can you do to protect yourself against that radiation in space?
Well, the canonical thing that they've done is thick aluminum shells. By thick, I mean 3 millimeters. This is enough to start to break a lot of stuff, but it's really not going to help you enough against those cosmic rays. Alpha particles, cool. Beta particles, cool. Gamma rays, they'd rather you have a lot thicker of a layer, but this is a start. Unfortunately, what you really need is a layer of soil or a layer of water surrounding you.
Like a lot of protons,
Yeah.
right? And the I
And
mean of those three things we talked about, of the of the trapped radiation and the material coming from the sun, those are relatively easy to block. They're not moving with a lot of speed, your aluminum, etc. But it's the cosmic rays, the chunks of supernova that are coming your way. Those will just go right through all kinds of material.
well, and so will the gamma rays and X
Yes,
rays.
yes,
And so all the basically the more likely it is to kill you, the harder it is to stop. And this is where we start getting into weight issues as well. Human beings, we're giant bags of water. We're giant bags of water that need food, we need air, we need water. And the question becomes, how do we protect ourselves and any other life we might be taking with us from all of that radiation without making our spacecraft weigh so much that it becomes intractable for us to get there?
right.
Various pie in the sky ideas that have deeply amused me, but I don't think would work, include things like, well, have your water stored in the outer hull of the spacecraft and fill it with tilapia while you're at it. I don't think that would work. That would have a really bad moment of inertia.
But water is heavy.
Uh, Water's heavy, and it would have a really bad moment of inertia. Uh, there have been people who've talked about, well, let's just generate a magnetic field. That requires a ton of
Yeah,
electricity.
yeah. I think
And to,
just to go into that for 1 second, I did a whole, I've been following this space very carefully about like just generate a
yeah,
magnetic field. I'm sure a ton of the listeners listening right now are like, why don't they just make an artificial magnetic field? We know how to run electricity through a wire and make a magnet. I mean, people have been struggling with this idea literally for 50 years, and even with superconductors, with incredibly powerful power sources that we have available to right now, just the they still can't make the power and strength of the magnetic field that you would need be compared to just dirt or water. Like, still, dirt, water, aluminum is a much better plan than attempting to generate an artificial magnetic field. Now, it could happen in the future, but for now, we don't have any way to be able to do it. And this idea, NASA has paid multiple times for studies to try to solve this. There was the folks at CERN had recently done some research on this as well, attempting to generate a superconductor magnetic field, and it would be great. Where you flick a switch, boom, on come the shields, just like Star Trek. And unfortunately, we just that so far that technology has eluded everybody who's attempted to do it. But there's still people. There are probably a dozen people still trying to work on this technology.
and one of the great frustrations with magnetic fields is they also, like so many other things in science, follow what's called a 1 over r squared rule. This means as you get further from the center, the field strength goes down as the square of the distance. So you triple your distance, you have 9 times less magnetic field. Now, the inverse of that is the closer you get to the center, the worse the magnetic field. And I remember when I worked at Harvard, at one point, we were moving the ginormous magnet that was from an NMR machine. And I was warned, do not stick your head inside the magnet. Your brain won't appreciate it.
Right. Right.
I'm not sure I want to have to live inside of a small magnetic field with a 1 over r squared law, which means I am always experiencing more magnetic field than I might appreciate.
Right. The So the other idea, of course, and the future colonists that are all on their way to Mars or the moon, is just live underground. Just get, as you said, get some dirt between you and space. Do you remember Seven Eves? Sort of at the
Yes.
end of the book, a bunch of people settled in a crack deep down, but still exposed to space. But just by reducing the amount of, being at the bottom of a chasm, you just minimize the total amount of space that's shining down on you to just the stuff that's going to be directly overhead, and really dramatically minimize the amount of radiation that you're going to receive. So you don't have to necessarily live underground, but you definitely don't want a lot of sky.
This is where what you start imagining is the high-tech version of the Mesa Verde people. Here in the United States, out in the Colorado Four Corners area, there were peoples that were cliff dwellers. They built into the sides of these amazing canyons, vast cities, and they just existed in the cliff caves and had amazing architecture. And someday we may be replicating what they did, uh, except instead of being the Anasazi, it's going to be us.
Right.
And I'm cool with that. Let's become the mole men of Mars, the cliff ladies of the moon, and see what we can find to live with down deep in the craters.
All right. Well, you send me a postcard. I will enjoy living here on Earth, where I get to just live outside and see oceans and trees and stuff. But
Okay.
all right, all right. Well, thanks, Pamela. We'll see you next week.
My pleasure. Talk to you later. And now we save. We 5:15.
Yes. People are having a slowest modem war in the chat. What was your first modem?
2400 baud.
Yeah, mine was a 2400 with 96 compression, I think.
I don't remember that. Um, I just remember the noise. I think that's a noise that will never
Yes.
leave my head.
Yep. That's awesome. All right, I've saved mine. James Aberson asks, if you use water, does it become contaminated? So if you do surround your spacecraft in water and it's getting pelted by particles, doesn't it turn into heavy water bit by bit?
It can turn into heavy water, but uh, unless it hits the point of being tritium, you're still okay.
Yeah, and I think people have shown how you can drink heavy water. Um, Larry Beckham and Arjone are asking, how can we protect the electrical grid on Earth? The Carrington event was something in the 1800s.
Well, what we do today is we stick spacecraft between us and the sun. I'm looking at you, Solar Dynamic Orbiter. And because particles travel slower than light, these spacecraft are able to see the coronal mass ejection, go, hey, Earth, heads up.
Yeah. And then just watch
Because they're
sadly
so
as
much
Earth doesn't
closer to the
do
sun.
anything with the heads up. Right.
Well, so if so, the next stage is since particles do travel slower than light, they will hit the spacecraft, and this spacecraft will go, holy particles, expletive, help! Send that information back to Earth. And that information will lead to spacecraft getting safety, the power grid having the power on it reduced. As long as this stuff doesn't hit during the summer, we're pretty okay. The issue becomes when it hits during the summer because the power grid in general gets overrun with all of the air conditioning. This varies by nation. In countries where you have the majority of the indoor heating requiring electricity, there it's the winters that they shut down, the winters where they have concerns about this sort of stuff. So the moral of the story is live where you don't need AC and heat using something other than electricity.
Bill K is asking, what do you think about the higher res images of MU69? Have you seen the new picture? The new
Wait,
high
Was there
res
one that
picture.
came out today?
Came out yesterday.
I have been in government shutdown,
Yeah,
headache induced land. I
yeah,
admit to that.
yeah. It's awesome.
Okay, pulling it up.
I'm gonna try and find.
2014 MU
I'm
69.
gonna try and find the picture just so people can see it.
Um,
All right, here we go. This'll do. All right, I'm gonna share this picture so everyone can see it.
I'm not finding it.
Well, here you can look at my screen.
Ah,
So,
it really looks like it has a smushed in face. I see two eyeballs and a smushed in face. It's an angry pug.
yeah, that's awesome. So cool. I'm just so excited to see this picture. Just another thing in space that we get a chance to see up close. And when you think about just how far away it is, just amazing.
Yeah, it really is.
All right, this is going to be very confusing for you. Let me just shift that back over. All right, let's move on. Um, Quadlibit is asking, is our own solar radiation protecting us to some degree from the nastier cosmic rays?
No,
Well,
it just compounds.
the heliosphere does. So the
That's true.
bubble
That's
of
true.
right. So when you think
Yeah.
about a long, the radiation is blowing off the sun. That's expanding out the heliosphere, and the heliosphere is decreasing the amount of radiation that we receive on Earth thanks to the sun. So yes,
But once it gets into our solar system, which was the restricted regime I was thinking about, the sun is no help.
right. No, no, it's just cheering on the radiation. And so Linda said he's saying is if the spaceship was shielded with water and used for the crew, wouldn't the radiation be absorbed and ingested by the astronauts when they drink it? The
I
radiation is
so
done, right? Like it's already
yeah. So the issue is these particles have two different kinds of energy. There's their intrinsic energy because E equals mc squared, but then there's also their kinetic energy, and it's that kinetic energy that's actually the problem. So you have a ionized nuclei that gets accelerated in some distant magnetic field to it's basically going plaid if you remember Spaceballs. And that particle that is going plaid, when it hits one of your molecules, that molecule is like, and I'm done, and breaks. And if that molecule happens to be your DNA, it's a bad day.
right.
Now, if instead that particle hits the water's like, okay, I'm two hydrogens and an oxygen. Oh, look, I've reformed.
Right. Now
Um,
I'm two hydrogens and an oxygen that have broken
Still,
apart. And now
yeah,
the hydrogens find oxygen and come back together.
yeah. So it's all a matter. I have a stink bug climbing across my desk. I'm sorry to be distracted, people. I'm just doing the please don't come near me stink
It's
bug
a little
look.
early in the season for bugs.
So I had my space heater on, and everything that was hibernating in the walls decided to come out of the walls. I live in an old farmhouse
Yeah.
from the 1890s. It leaks, stink bugs, badly. Um, yeah, yeah.
Kevin N is asking, would radiation exposure on or near the moon be more or less during a lunar eclipse?
I Issues of particles coming from the sun would be less, but stuff coming from galactic radiation isn't going to be affected.
But the sun's takes 8 minutes for the flare, and then it can take several hours or days from the particles from a super flare to reach the Earth. And so, if the flare happened days ago or hours ago, and then
But
the lunar eclipse happened, you could imagine a situation. But then the storm can last for hours. So there's
well,
no real avoiding it.
yeah. If it is a brief flare, the amount of time that the moon spends in the eclipse could actually save its butt.
Right.
Um, it all depends on the timing of such things. And I no longer know where the stink bug is.
Or hide behind a rock.
Oh, there it is. Okay.
Um, yeah, there you go. Paranor says you should call Stella and Eddie to save you.
Yeah, they would just eat it. Or Eddie
Exactly.
would.
Precisely. You would be saved. Aw.
It does not want to focus.
Maybe put it near your fish food. No. Oh, there it is. Wait. Got it.
Yeah. So this, I'm going to go dump this in the toilet now that I have it confined. I will return in
Don't.
just a moment.
Just put it outside. Don't make me tell my wife.
If I put it outside, it's going to die slower because it's
Mm,
minus a lot.
all right. All right, I'm going to take some questions while we're going. So back to the question of the Carrington event, right? This was this enormous event that happened back in the 1800s that was so energetic that it sort of ran electricity through telegraph wires, lit telegraph towers on fire, and things like that. And so we've even seen events as strong or stronger than the Carrington event. They just didn't happen to be going anywhere near the Earth. And the solution to this problem is to not have a completely interconnected electrical grid and information system. So instead of, when you think about, say, you connect two houses together with electricity, if the power goes out in one house, it also takes out the power in the other house because the two are on a circuit. If you connect the entire eastern seaboard of North America into one big circuit, any part of that grid goes down, it takes the whole thing down. And this is the
It
problem is that
depends on how it goes down.
and it depends
So,
on the redundancies that they have in place. It depends on the circuitry that they're doing. But just in general,
yeah,
connected devices, you get the advantage that they're connected, and so you can run electricity between two things and get, you can have two light bulbs in a circuit. You can run electricity through it and both light bulbs come on, but the problem is you break the circuit at any point and both light bulbs go off.
yeah,
That's the downside. And so we need to move to an economy or some kind of electrical system where everything isn't so connected, where people have solar panels on their houses and they have battery systems in their houses, and your neighbor has something similar, and you can
yeah,
share power but you don't have to share power, and if my
yeah.
house goes down it doesn't take your house down. It's those connections that puts us all at risk, and the fact that we don't just live in Faraday cages all the time, but
And bury your power lines.
bury your
All of
power
you who
lines
live,
and
yeah,
use more radio-based communication systems as opposed to, and use fiber optic cables as opposed to electrical cables. So there
yeah.
are a bunch of, and you can harden electronics. So there's a bunch of things that we know how to do. It's just they're more expensive than the things that we do right now, and the price that we will pay is if a severe storm comes along, it can dramatically damage our modern economy. So
As we get more and more advanced, things are also getting more and more fragile in general. And it's sometimes ridiculous. I have more than once found myself in a situation where I couldn't figure out how to turn my office lights off because I had, like, my phone died and there was a bookcase in front of the light switch. Ridiculous modern day problems. Uh, Affluent white people problems. But we also have, you can't necessarily fix your car, you can't fix your John Deere tractor because everything is DRM'd. There was a fascinating thought experiment yesterday on Twitter of, if Tesla goes out of business, does that mean that your cars all brick themselves?
yeah.
Because Teslas are constantly demanding software updates and periodically won't start without a software update. So what happens? DRM is
Yeah. Yeah.
a
So,
thing.
yeah, yeah. So, I mean, these are the unintended consequences. So, and we won't know. People with pacemakers, things like that, right? So there are all kinds of reasons why we should think about the potential for a powerful solar storm to cause us to and the impact, and to think about what kinds of preventative. And we do know what to do. It's just it's expensive, and
Yeah.
it's more expensive to bury power lines. It's more expensive to switch to fiber optic cables. It's more expensive, etc. So anyway,
You need to go.
people are just. I've got another like 5 minutes.
Okay.
People are just talking about bugs in the chat.
So stink bugs, marmosetted stink bugs are a invasive species from Japan. They can flatten themselves out so much that they can fit through all of the windows in my house, and they live off of fruit. They have no natural predators where I live, other than perhaps Eddie. And so what happens is, since they see in the infrared when the temperatures outside begin to drop, they seek places to hibernate.
Mm.
And in this case, the place that they chose to hibernate was their favorite three places in my house are curtains and shades. There was one point several years ago where we started Astronomy Cast late because when I closed that blind behind me, one of the Roman shade stripes was covered in like 100 stink
Oh
bugs.
wow, that's a party.
Yeah, it was really gruesome. We go through about a week every year where we just keep the vacuum out and we walk around vacuuming off the Roman shades. So they love curtains and Roman shades. They also love to get into piles of clothing. Uh, and
That's so funny.
yeah, and so whenever I turn on a space heater, they suddenly are like, "Oh, it's not 62 degrees in this house," because we have more house than two people who randomly decide not to have children after buying a house actually need.
Yeah.
And I have a puppy.
We
Um,
oh we have those stink bugs, but they're not bad, and they mostly stick to fruit. And so you'll be going out and eating berries, and every now and then you examine every berry very carefully,
yeah.
because it's just a matter of time before you pop one in your mouth and you're like, oh, that was a bad berry. Um,
Yeah.
and the
So here it's you shake all your clothing out
oh
and
wow.
occasionally hear the stink bugs flying away in the
Yeah,
process.
yeah, we get the carpenter ants is our version of that, and we get sleepy wasps. Sleepy like
What the heck is a sleepy
well,
wasp?
sleep. So like a wasp will hibernate, same thing, right?
Oh, yeah,
Like a
yeah,
yellow
yeah.
jacket, and you'll find them in your clothes or under, in a box, or things like that, and and they're
Yeah.
they're pretty dopey, so they don't sting you right away, but they can kind of wake up if you aren't careful, and they'll get you. So, but
Yeah,
we
we have
don't.
mud wasps. They don't come inside.
No, we have mud wasps as well. They're fine. But it's so funny, like when I moved, when Carla moved to Canada with me, we, she lived in a place where every part of the flora and fauna is trying to hunt you down. The grass is filled with snakes, the bugs fly around and they try to chomp on you. And we just don't have any of that here, right? Well, except for bears and cougars, maybe. But we don't have any of the.
Do you have grizzlies or black
We have black
bears?
bears on the island, but British Columbia
Okay,
it
yeah,
has
they're harmless.
has tons of well, they're not harmless. They are less
Oh,
harmful than a grizzly bear, but black bears still kill and eat people in British Columbia every year, and we have the highest
you have really
concentration of
dumb
cougars.
people.
No, but I mean, you go out into the forest, there are bears out there, and you run across them all the time. And most of the
Okay.
time, they run away from you, and every now and then, they don't. So, and with cougars, they like to chase things that are moving fast. So,
Yeah,
um,
they will eat you.
they can. Again, every couple of years, someone gets eaten by a cougar. But we don't have snakes. I mean, we have little garter snakes, but we don't have anything that's very
Okay.
poisonous. So you can move through the grass with reckless abandon. And so the problem was that I have no safety protocols in place, because we would just go through thick grass and not even think about it, right?
You don't have poison ivy.
No, we don't have poison ivy. We don't have poison oak. We don't have any of that. We have like
Oh
stinging nettle,
man.
which is like a little annoying. But in
Yeah.
general, yeah, we just tromp through waist deep foliage without a care in the world. And without shoes and socks on, just in your shorts, just run through the grass. So needless to say, Carla's like, "What are you doing?" As I was like walking through the grass, because in Louisiana, every third piece of grass is actually a coral snake. So, right, and that spits out rattlesnakes or something. Anyway, so it's a very different environment. I've since learned, but
I love the concept of a coral snake spitting out a rattlesnake.
sure, yeah, it could happen. Yeah. All right, I think it's time to leave. I'm gonna wrap things up so that we can go. Thanks, everyone, for watching. Thanks, Pamela. Thanks, one of your dogs. Which dog have we got?
Stella.
Hey,
This is
Stella.
Stella.
Aw. And thanks as always to our good friends at the Weekly Space Hangout crew. If you want to join this amazing community, go to wshcrew.space. And we will see all of you next week. Thanks, everyone.
Bye bye.